Hello everyone, I am your teacher Keith, and in this video, we're going to talk about the important and the powerful tool in abstract algebra, the one-step subgroup test. Let's learn together by watching Mathematics. So before we start, let me define first what is group. So a group is a set of G along an operation that satisfies four main properties. Before we dive into one-step subgroup test, let's remind ourselves what is a subgroup test is. The subgroup test is a method used to determine whether a given subset H of G is actually a subgroup of G. The subgroup test is based on simplified criterion that ensures the subset H satisfies the necessary properties of a subgroup: the closure, identity, and inverses. And now, these conditions can sometimes seem like a lot of work to check, but the one-step subgroup test simplifies the process and saves us time. Here's the good news. You don't need to check all the properties of a group separately. The one-step subgroup test tells us that to prove a subset H is a subgroup of G, we only need to check three key properties. First, identify element of G is in H. Second, H is closed under the group operation. Third, H is closed under taking inverses. First, we need to check that the identity element of G is in H. This is important because every group has an identity element, a number or object that doesn't change other elements when combined. For example, in addition, the identity is 0, and in multiplication, it's 1. If H doesn't contain the identity element of G, then it can't be a subgroup. So this is the first thing we need to check. For instance, let's say G is equal to Z, or the integers under addition, and H is equal to 2Z, or the even integers. So the identity element of G is equal to 0. Since 0 is in H, this property holds. And we need to check the closure. This means that when you take two elements from H, their operation like addition or multiplication should result in an element that's also in H. If A and B are in H, then A plus B, or whatever the group operation is, must also be in H. If this isn't true, then H can't be a subgroup. For example, so let's go back to the G is equal to Z, or the integers under addition, and H is equal to 2Z, or the even integers. So if we take two even numbers, let's say 4 and 6, and add them, so we get 10, which is also an even number. So H is closed under addition, which means this property is satisfied. Finally, we need to check the closure under inverses. This means that for every element in H, this inverse must also be in H. For example, if A is in H, there must be some element B in H, such that A plus B is equal to 0, or the identity element of Z. If it's not true, then H can't be a subgroup either. Again, if we take H is equal to 2Z and pick 4, its inverses in addition would be negative 4, which is also an even number. Therefore, H is closed under inverses, and this property holds. Since all three properties are satisfied, we can confidently conclude that H is a subgroup of G. And now that we know the three properties that we need to check, so let's talk about the importance of one-step subgroup test. The one-step subgroup test simplifies the process of determining whether a a subset is a subgroup. Rather than checking everything individually, we focus on these three properties, which are easier to work with. So let's quickly review on what we have learned. The one-step subgroup test helps us to determine if a subset H is a subgroup of G by checking these three properties. First, the identity element of G is an H. Second, the H close under the group operation. And the third, H is close under inverses. These three properties are simple but powerful, and knowing how to apply them will make your work with your groups much easier.